Hello and welcome back to Calculus 3. We are going to discuss calculus of vector-valued functions. We know that the vector-valued function is a collection of three functions which are all dependent on the same parameter t. And we know that calculus consists of limits, derivatives, and integrals. How do we do calculus with vector-valued functions? Well, we just do it term-wise, function by function, independently. And the lecture is over. You take three limits. They're all independent functions. You take three derivatives, and you take three integrals. That's all. Lecture over. You want one example? All right, fine. Let's do an example. So, compute limit as x goes to 0 for r of t. Compute the derivative in respect to t and compute the integral dt for r of t given as x squared plus 1, t squared plus 1. That's what I said. Please pay attention. Thank you. T squared plus 1 cosine t a to the t minus 2. Remember, you're doing this component-wise. All right, are you done with all three? Since there is so much chatter. We start with the limit. So, the limit of vector r is going to be individual limits of each one of the functions. So the first one will return 1, the second one will also return 1, and the third one will return -1. Very good. So it is a vector 1, 1, -1. Now that points towards the point 1, 1, -1. The next concept is the derivative. So r prime, that's good enough to write, just r prime. The derivative is 2t, negative sine t, and just e to the t. Note that I did not ask you to compute this at any point. I could say find the derivative at t equals something. So t equals 0 or t equals. So that would be then additional step for you to compute the actual vector. So this is just the derivative vector. And then finally the integral of vector r dt would be, now we're integrating, so we have t cubed over 3 plus t, and then we have sine t, and then we have e to the t minus 2t. Now I'm going to write this in blood over here, plus c1, c2, c3. I know, did you forget your plus c?
No, I didn't, but why does it have to be outside?
It doesn't. You can have plus c1, plus c2, plus c3. It cannot be plus c, plus c, plus c. What do you mean whole?
Like if you have at t plus 0 when something equals 0 to 0.
We use L'Hopital rule. You mean what happens if the limit doesn't exist? Then the whole thing doesn't exist. As if one of the components, just like a car, if one of the components doesn't work, the car doesn't work, right? It's just the engine block is, shot. The rest is okay. I mean, I have new tires. You can practically just roll it down the hill, right, George? I just can't repeat all of that. It's just lost. The moment is lost. So you can have this C1, C2, C3 added to each one, or you can just have an additional vector which adds to the first vector. Okay, now, very important business. This thing will be showing up a lot. It's called unit tangent vector. So definition for the unit tangent vector is let R of t be a smooth parametricized curve for a less equal than t less equal than b. The unit tangent vector is given by, I'm going to put t hat because it's a unit vector. It's r prime of t divided by the magnitude of r prime of t. So what is first tangent vector? When you have a curve in space of some kind, let's put a coordinate system. So you have a curve. There is going to be a tangent vector and since it's a unit tangent vector, its magnitude is 1. That explains this part of the formula, because you know that when you divide u by u magnitude, you get the unit vector, right? You learned that so far, hopefully. So the denominator of the equation, just make sure that the unit part is ensured. Now look at the numerator. It's a derivative, right? Don't we know that we find the tangent lines when we take the derivative from Calc 1? So this formula shouldn't be anything out of space, right? The tangent vector we find when we find the derivative and we divide it by its magnitude to get the unit vector. So unit tangent vector. The title tells you the formula, if you understand anything here. Now the unit tangent vector in space shows the direction in which the object is moving. That's the direction in which the velocity is pointing at all times, except we are scaling it down to 1 and have it as a unit tangent vector. So example, find the unit tangent vector for r equals 3 sine t, t squared, 3 cosine t. What is this? Helix. Oriented which way? Wrapping around y-axis. Very good. All right. Find the unit tangent vector.
Okay. I guess.
Yeah.
So you simplified the magnitude by using the cosine squared plus sine squared equals 1.
1.
So why? Why is it still 9?
When you factor out 9, right? When you add those two, you factor 9 out, and then it's 9 times 1, which is 9.
Right.
The question is, can you do the cross product between the two vector valued functions?
The answer is hell yes.
Yep. Now, if you are to do the derivative of the cross product of two vector valued functions, what would you have to do? You would have to do the product rule, where each one of those products is actually a cross product. So that takes forever. Right? So
if we simplify it and just left it how it was, like squared,
this is not the problem that you have to worry about, right? Because this is just showing the concept. This concept of the tangent will show up in calculations for other things, and if you don't simplify it, you're just going to have a hell of a time computing the rest. So I believe I answered your question. So what is the derivative of u cross v, where both of these are vector valued functions? Well, actually, it's the product rule that has cross product everywhere. So it is u cross v prime plus v cross u prime. And each one of these, right, it's derivatives of vector valued functions. So you will have to do two cross products on the other end, and they're all functions in terms of t, so it's a lot of nasty algebra. So all of the rules that you learned before, they still hold. Dot product is also going to be the product rule, and then addition, subtraction, constant multiplication, all of that stuff stays the same. The one thing that you might benefit from for homework exams and so on, but also for your careers later on, is how to compute C1, C2, C3 when you have indefinite integral. So what I want to do is first do the Calculus 1 version, and then we are upgrading and doing exactly the same for Calc 3. So say you have integral of x squared dx, and you are given that f of 3 is 84, whatever, I don't care, right? So we know that when we integrate, we are going to get a function x cubed over 3 plus c, which actually gives me infinitely many of these x cubes stacked on top of each other forever. Only one of these functions will go through the point 384. Only one of them. So I can say that 3 cubed over 3 plus c is equal to 84. Because I am taking the answer that I got, right, the antiderivative, and I am using the point x is 3 and y, which is the answer for the function, right? Y is 84, and when I plug those in, I get c is equal to 84 minus 9 equals to 75, which means that the function that I'm looking for is 1/3 x cubed plus 75. If you remember this and understand this from Calc 1, now you get to do this 3 times in your vector valued function for Calc 3. So say your vector r is given as 2t cubed a to the t minus 1 and what else? 5. I don't care. All right. And you are also given that the r of let's say 1 is 6, 0, and 2. So now once you integrate the vector 2t cubed e to the t minus 1 and 5 dt, you will get t to the 4 over 2 comma e to the t minus 1 and 5t plus c1, c2, c3. Or if you added immediately c1, c2 in this parenthesis here, I don't care. Whatever you like. So now, what do I have? I have t to the 4 over 2 plus c1 is equal to 6 e to the negative 1. Oh, sorry. I'm supposed to plug in 1 over here, 1 to the 4th. Because t is 1. E to the negative 1 plus c2 is equal to 0. And the last one is 5 times 1 plus c3 is equal to 2. So this is 1/2, so 5.5. So c1 is 5.5.
Why is that negative? Wait.
Oh yeah, t is 0. Thank you. Yeah. T is 1. So 1 minus 1. Let me write it. E is 1 minus 1. Yes, it's 0. So it's 1. So c2 is negative 1. Thank you. And c3 is 2 minus 5, negative 3. So we get to write the final answer as 1/2 t to the 4 plus 5.5 comma e to the t minus 1 minus 1 comma 5t minus 3. And that's the answer. So we were able to determine C1, C2, C3 for indefinite integral, and all I did is calc 1 all over again, except we had 3 separate calculations for each one of the components. Ta-da! Right? Want another example?
Yeah.
You all good? You want more? No more?
Go either way.
All right, okay, let's say bye to the stream.